Thank you very much, and good morning, everybody. Hopefully jet lag is not gonna crush me in the next 34 minutes. Let's see how this goes, okay? So today I'd like to introduce you to what we build at Hugging Face. Hugging Face is a French-American startup, and we do machine learning. And we do it in a way that helps you go pretty quickly. I will try to show you lots of things today. So let's just get started. So this is probably what some of you or a lot of you are doing today. This is how the world sees machine learning, which kind of becomes a synonym for deep learning in many places. So we start with neural networks and neural network architectures. We spend an insane amount of time cleaning and preparing and labeling large data sets. And I guess a lot of the sessions here are going to be talking about that. I'm not, right? So hopefully that's good news. And then we put those models and those data sets together. And we use compute in the shape of GPUs most of the time to train and get to a model that we like, that's good enough for production. And how do we do this? We do this with a bunch of tools, right? A lot of open source tools, actually. And don't get me wrong, they're great. I love TensorFlow and PyTorch as much as anyone else, but they're still very difficult to use, right? And the problem here is, unless you have solid skills in machine learning, deep learning, computer science, statistics, and all that good stuff, it's pretty difficult to actually get to production-grade models. So that's what a lot of people do today. That's what we're trying to reinvent. First of all, in the last few years, we've seen transformers, a new architecture for deep learning models, become extremely efficient over a wide range of use cases. And they actually tend to become the de facto solution for a lot of problems, as you'll see. Instead of building and cleaning and labeling crazy large data sets, we start from pre-trained models, off-the-shelf models for whatever task you're trying to solve. And we use this amazing technique called transfer learning, where we inherit from knowledge that is lying in the pre-trained model. And so maybe we can just use the model as is. Maybe it's just good enough for our purpose, and that's fine because we just saved ourselves the trouble of building a machine learning project from scratch. Or maybe we fine-tune it, we train it just a little bit more on a bit of data that we have. And the key word here is a bit of data. We're not going to need millions of labeled samples. A few hundreds, few thousands, and sometimes much less is actually going to do the trick. GPUs are still around, but we also see a new generation of chips coming up on the market to speed up training and inference, chips that have been designed from the ground up to accelerate machine learning, right? And as we all know, GPUs were just designed to play 3D games. Nothing wrong with that. And last but not least, we're trying to do all of this now with developer tools, right? And I want to underline developer. We try to build tools that make it easy for anyone to do this stuff, okay? So you don't need to be an expert. You don't need to write thousands of machine learning code, right? You can do it, as you'll see today, with very little code, very generic code, and very simple code. So transformers are those new models that were introduced in 2018. You all heard about BERT, that Google launched. Transformers is also the name of an open source library that we steward, right? Of course, we have a huge community around it, but we kind of lead that effort. And in fact, Transformers is one of the fastest growing open source software projects ever. And that's a bold statement, but I think we can back it up looking at GitHub stars. And this is even from a few months ago. The Transformers library is the yellow line on the left, with the steepest slope. And not only do we grow in popularity faster than excellent projects like PyTorch or Keras or Spark, hopefully I'm allowed to say that here. No one's going to send black choppers my way. But we also grow faster than Kubernetes or Node.js, which is a bit mind-boggling to me. With this library and our companion website, which is called the Hugging Face Hub, which you'll see in a second, where we host models and datasets, we serve over 1 million models every day, right, and counting. So we have crazy adoption in the open source community, and we also see analysts and industry experts catching up. So the State of AI report said transformers are emerging as a general purpose solution for ML. So if you thought transformers were just good for NLP, yes, they're still excellent for NLP, but they also work very well for computer vision, speech, reinforcement learning, and a few more things. We have plenty of seats around here. There's no risk in sitting in the front row. I'm not going to pick on you, right? No worries. Even if you write Python on Windows or something, yeah, you're safe, right? No problem. And the Kaggle survey told us that we see a recurrent neural network and convolutional neural network usage going down and transformers usage going up. So really, we're becoming that de facto solution. So I don't have a lot of time today, so I'm going to go straight for the throat. That's the family picture for Hugging Face. We host over 5,000 data sets. By now, it's probably 6,000 on the Hugging Face hub at huggingface.co. We host 55,000 plus models on the hub. And putting those two together, working with the Transformers library, you can train and experiment anywhere that you'd like, on your laptop, on your GPU server, in the cloud. We have additional libraries for hardware acceleration. If time permitting, I'll give you a quick sneak peek at that. We've built Spaces, which is a really cool way to showcase machine learning model for non-technical stakeholders with simple web apps. I'll definitely show you that one today. And we have a managed inference service called the Inference API that lets you deploy and predict with your models in one line of code, right, on managed infrastructure. And obviously, we have partnerships with large cloud vendors like AWS, SageMaker, and more recently, Azure, where you can, again, one-click deploy any NLP model from the hub on Azure infrastructure. Literally one click. Okay, so that's the family picture. Now let's run some code. And I'll need my glasses for that. Okay. So this is the Hugging Face hub, if you've never seen it. Who's never been to the Hugging Face hub? Come on, don't be shy. I barely know this stuff. Okay, a few people. I'm still guessing you're shy, but okay, a few people. All right, okay, so this is where we have 50K models and 6,000 or something data sets, right? And this is like the, the raw material that we're gonna use to build our applications, okay? So let's say that I wanna run, I want to build train a model to solve a real life problem here. You can find all that code on GitLab, right? You can ping me later if you can't find it. GitLab.com, Julien Simon, blah, blah, blah. You'll find it, okay? It's part of a larger workshop. So what I'm trying to do here is I want to train a text classification model that takes Amazon product reviews for shoes, right? Everybody's obsession. And predict the star rating from 1 to 5. Okay, so that's what I'm trying to do here. So first of all, I would go to the Hugging Face hub. I would try and find models that are pre-trained for that. So you're going to find sentiment analysis models. You're going to find all kinds of models. But hey, you're not going to find that model trained for shoe reviews and star ratings. Okay, but we're going to find models that are close enough. That have been trained on very large text corpuses, models like BERT, Roberta, DistillBERT, who can understand the finer points of the English language, which is what we need here. And we can start from one of those. Accordingly, we're going to need data, right? So, well, we could go and scrape Amazon.com, But as it turns out, we do have the Amazon US reviews dataset readily available on the hub. And this one has millions and millions of product reviews, including a shoe category, which is exactly what we need here, right? And we can see it here. We can browse it on the hub and check that, okay, yes, we have product titles, reviews, and star ratings, etc. So that's what we're going to use, okay? So first of all, of course, I need to do a bit of data prep. So that's not going to be too difficult. I'm going to install the datasets library, which is one of our open source libraries. I'm going to download the dataset, okay, which is literally one line of code. And I can see this is a really big one. And for experimentation, that's probably too much. I'm not going to need 4.3 million shoe reviews, right? Training time is going to be too long. So I'm just going to say, well, can you just give me 10%? Okay? So now I'm down to 436K reviews something. There's plenty of information in the data set, but most of those columns I'm not really interested in. Okay? This is an example here. I'm really want to focus on the review itself and the star rating. So I can just drop all those columns, and now my data set looks like this. Okay? Really quickly, I wanted to run a sanity check on my star ratings, make sure they really are from 1 to 5, which is the case here. And I want to see if that data set is balanced or not, right? And in fact, it's not at all balanced. I have a lot of 5-star reviews, because Amazon only is selling great stuff, as we know, right? But still, from a machine learning point of view, this is a problem because I have way too many 5-star reviews. So what I'm going to do is just rebalance the data set and have an equal number of reviews for each star rating, okay? And so that takes me to 100K ratings, again, which is more than enough for experimentation. By the way, you can see how quickly I can go through that stuff with the datasets library. If you're familiar with pandas, this is very, very similar. You'll be right at home. One problem I need to solve is that machine learning labels need to start at 0 for classification, right? So I can't have 1 to 5. I need 0 to 4, okay? So I can write a very simple function that simply decrements the star rating and apply it in one line of code to my data set, okay? And I also need to rename those columns to the feature names that the model actually expects. So here, the model expects a column called text and a column called labels. Okay, and now I'm good, right? So 10 lines of easy Python, and I prepared this data, right? And I ran all of this on my laptop. Okay, I'm going to split it for training and validation, and then I can save it locally, right? Obviously, I can reload it from the disk. I'm going to save it to CSV because that's always useful. You can use all your CSV-based tools for additional exploration or processing if you'd like. I can save it back to S3, right? Its original home, because the datasets library is integrated with quite a few cloud storage services. So that's just one line of code again to load it, to save it to S3 and load it again. Very convenient. And of course, I can push it to the hub, right? Because I want to share it. I want to store it, and I possibly want to share it with people in my team or other teams or maybe the community, right? And so pushing that data set to the hub is a one-liner. And what this really does is it's going to create a Git repository on the hub and push the data there. And we should be able to see, we should be able to see this data set here, right? We see the Git repo, which is managed by the Hugging Face hub, and we see the data files, which are actually Parquet format, okay? Of course, we could have used a normal Git workflow to do the same, okay? So that's it. The datasets library in a few minutes. You hardly need to read the doc. You can load data from the hub, prepare it, push it back to the hub, and now you're ready to train. So let's go and do this. Or should we actually go and do this? Maybe not. Maybe we should use AutoML, right? Because we don't quite know which model is going to work best. So how about we use AutoTrain, which is part of our services. So let's go and do this. Amazon shoes Databricks. This is a multi-class classification problem. I want the service to pick the models automatically. I want to use English. And of course, I want to use the data set that I just pushed. So I want the training set for training, right? Mapping the columns to what they should be. And I want to do the same thing for the validation set. Add to project. Go to trainings. Yeah, why not 15 models? Start, go. Okay, now this stuff is running in the background, and I can go back to other things, right? But this will run 15 jobs, and this will tell me, hey, this model architecture actually works pretty nicely on this. So this is going to run for a little bit, as you can guess. I've run this before. This is what it, oh, no, that's not the right one. This is the one. And so I can see this trained 15 models. I get all my usual metrics, okay? I can see the top accuracy model is this one. It's been automatically pushed to the hub. All this information that we call the model card, which is super important, has been automatically filled in for me, right? And again, you know, I can see the model file here. Okay, and I can see this is a Roberta model. Okay, but I would only know that once the job is complete, right? So now we're kind of fast forwarding a bit, but you can see how easy it is to run AutoTrain models. So assuming we don't know this yet, what we would do is go and experiment. Okay, so we would start from the transformers library, right? And if you haven't started yet on GitHub, I would appreciate that, right? Looking forward to the 100K stars. And here I'm going to train locally on this machine. So importing a few objects, starting from DistillBERT, which is kind of a smaller, you know, leaner version of BERT. The reason I'm picking this one is because it's smaller, it trains faster, it gives me a good baseline. Probably it's not going to do as great as Roberta, but this is a good place to start. I'm defining some simple hyperparameters here. Most important, the number of classes in my data set. I can load the data set from the hub. Still always the same, the one I prepared. Okay. All right. It's already been split for training and validation. I'll define a function to compute my metrics. Okay. Here I want accuracy, F1, precision, and recall. You know, because I like it complicated, but you could have a simpler function here. I'm going to load the base model from the hub, right? So here, those two lines are downloading the DistillBERT model from the hub and its tokenizer. Okay, easy. I'm defining a simple function to tokenize the text into tokens, integers, because that's what the model expects. You know, strings are generally useless for machine learning models. We want tokens. Then I can define my training arguments. Okay, so, you know, batch size, how often do we want to save the model, learning rate, etc., etc. And then I configure my training job. Here's the model. Here are the parameters, the metric functions, the metrics function, the training set, the validation set. Notice that this code is completely generic, and actually I copied, pasted it from another notebook. This is not specific to the task at hand. If you were doing image classification or audio classification or anything else really, that code would kind of be identical, right? So that's nice because you don't have to rewrite that stuff. You can use that high-level training API over and over again. Okay, now I'm calling train. Okay, and this trains for a single epoch to keep that training time short. Accuracy is a little under 58%. It's not awesome, but okay, it's my baseline. it would probably go up if I trained a little more and if I started to tweak. Okay, and I get all my nice metrics here. Then I'm going to save the model. Again, I can save it locally, and you guessed it, I can push it to the hub, right? So now I have my model on the hub as well, okay? Just like that. And I can share it with my team or with the community. Again, all that information has been processed, and I can even test it right there. So the model is loaded on demand, okay, which takes a few seconds. This is the inference API under the hood. Then we'll take a look at it in a minute. Okay, so this is thing we call the inference widget, and it's a really cool way to quickly test models without even writing any code, right? So you can send that model page to whoever and tell them, hey, take a look at the model, run your samples, tell me what you think. And here we see it's labeled 4, which really means 5 stars. Remember, we decremented everything. So it's a 72% 5-star rating, okay? Not difficult, right? Not difficult at all. All right, so now we have this model on the hub, and obviously we could download it again. We could use the transformers library to predict with it. We have this pipeline object that's super simple. Define the task type, pass the name of the model. As you can see, it downloads the model, and then I can just go do this, right? Call that classifier model and get my top scoring class here, okay? Simplest thing ever. You can go down one level if you want to control, you know, the tokenization process, or if you need to do pre-processing, you know, on the pipeline, etc. And it kind of works the same. Download the model, tokenize the inputs, as you can see here, and then pass those input tokens to the models, and you get your probabilities, right? So, okay, looks like we have a model that's good enough for POC. Yeah? How long did that take? About an hour of training, 10 minutes of copy pasting, and okay, maybe 15 minutes of cursing because, you know, you forgot a semicolon or something like that. It happens to me a lot. But anyway, once you know how to do this, you know, and I'm slow, you know, you can do this in a couple of hours, okay? So you can experiment very quick, and you can get to first model. That's not great, but okay, at least it's good enough for demos. Speaking of which, imagine you wanted to show this to your marketing director, right, or your CEO or customers, and they'd be scared, yeah? Sometimes I'm scared. You know, what is this thing? You know, what I wanted was a model to classify customer reviews, and you're showing me this insane sequence classifier output logits with floating point numbers? What? No, that's not what I wanted, okay? What I wanted is something user-friendly, okay? And something user-friendly looks like this. Okay? Now you're talking, okay? Now they understand what you're doing here. You can enter a customer review, and you can get stars and a confidence score, so to speak. Okay? And this is a really simple example, you know? We have much more complicated ones, of course. And how many lines of code is this? All right, well, we don't have a lot of time, so I'll give you the answer. 15 lines. Okay, and you can see most of the code is really extracting the label and displaying stars. And I'm sure there's a better way to do it, but any UI stuff gets me, you know, in trouble, so I try to keep it simple. What did I do here? I wrote this stuff. I tested it locally on my machine with the Gradio library, which is a web framework. This is loading my model, okay? And I created a space, because obviously this is Hugging Face spaces. I created a space repository on the Hugging Face hub and pushed that file to it, okay? And then he was kind enough to do all the crazy stuff for me, installing and blah, 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 and firing up containers and all the DevOps stuff that I'm really not interested in, because all I want is to showcase my model. And this is running on managed infra, okay? So Spaces is really great. Who here has been playing with the DALL-E Mini model, generating silly images? Okay. Did you notice the huggingface.co URL at the top? Yeah, that's us, okay. All right. If you don't know what I'm talking about, you've been disconnected from the internet for a long time, right? You can just go to Spaces and look for DALL-E Mini and you'll find it, okay? There are thousands more, and this is a really cool way to showcase your models. Okay, so now you've done that demo, and your marketing director is kind of happy and says, okay, keep working on it, keep improving accuracy, and you know how to do that. You can train it for a few more epochs on a little more data. You can go and look at that AutoTrain model, maybe, that is even more accurate than what we have here. And now you need to deploy it for real, okay? So the first option is to use one of our services called the Inference API, which takes this much code, okay? Define the URL of the model, pass an authentication token that you have in your account, and fire up a query, which is really an HTTPS post request, okay? And don't try using that token after the talk, of course. I'm deactivating it. Yes, you can use it in the next 5 minutes. All right. And you can see, well, the first time I'm calling this, it says, no, go away, no, go away. I'm loading the model because it's all on demand, okay? We could pin that model if you have an enterprise plan. We can pin models. You can actually do it. It's all self-service, so that models stay loaded 24/7. Here, I'm all doing this on demand. After a few seconds of yelling at this notebook, of course, and waiting, I can run the query again, and I see my scores, okay? Nothing else than this. No DevOps, no provisioning, anything. Just load the model on demand and predict, okay? So some of you may say, yeah, okay, that's really cool, but hey, we run on AWS, or we run on Azure. And that's okay, because I'm just going to show AWS here. You can deploy any model from the hub straight to Amazon SageMaker, which is AWS's machine learning service, with this code, okay? So all it takes is this, right? First of all, point at the model on the hub, okay? Create that SageMaker object called Hugging Face model, which is not difficult, and then call deploy on that object with an instance type, wait for a minute or so, and you have a managed real-time endpoint running on SageMaker, which you can use just like that, okay? And all the good stuff that comes with it, auto-scaling, multi-AZ deployments, et cetera, okay? If you want to do the same on Azure, you can go to the Azure Marketplace and check out, search for Hugging Face, and you'll find this feature called Hugging Face Endpoint for Azure, which we launched in preview a few weeks ago, and it lets you do the same thing with just a few clicks in the UI. Okay? So not only don't we write machine learning code, really, we don't even write DevOps code, right? And all that stuff is completely generic, I'm a total fraud, because all I'm doing is just copying and pasting from existing notebooks, right? I'm just not even writing most of that stuff. Okay, so 4 minutes. Now, you have your model in production, and you kind of predict with it, and it works, and you're happy, and everybody's happy, but it's just a tiny bit too slow, right? Transformer models are big models, right? Dilbert is not too big, but the more sophisticated they get, the bigger they get, like multi-gigabytes, and looks like we're heading for tens or maybe hundreds of gigabytes in the near future. So they're big models, and we want to optimize them, right? Optimizing those models means ripping them apart and figuring out what's slow in there, right? Anyone here has done code profiling? you know what I'm talking about. Machine learning profiling is even worse, right? You don't want to get there. It is insane work, and I can't do it. What I can do is use a cool library that my colleagues have built, and this is called Optimum. And Optimum is an open source library that you'll find on GitHub, where we partner with hardware vendors like Intel, GraphCore, Habana Labs, and a few more to be announced, to accelerate transformers, both for training and inference, right? So I'm just going to show you inference. And of course, this is an Intel machine, so I'm going to use Intel, right? So starting from that model that we've trained and that same data set, okay, I'm loading the model again, okay? I'm defining a very simple function to evaluate the model accuracy on the data set. And as a side note, I'm using another library called evaluate, which makes it very easy to evaluate any model against any data set and any metric, right? Generally, it's a couple of lines of code. And here I'm saying, hey, please start from my model, evaluate it on my evaluation data set, the one I pushed to the hub. The metric I want to use is the mean square error, and that's about it, okay? And I'm using a tool called the Intel Neural Compressor here, okay, which is a tool that's going to do quantization. So the 15-second explanation of quantization is this. Models are trained with 32-bit floating point values, right? And 32-bit floating point arithmetic, even with very fast chips, is more complex and takes longer than integer 8-bit arithmetic. So why don't we replace all the 32-bit floating points with 8-bit integers? Well, that's quantization, right? And you could say, well, wait a minute, we're going to lose a ton of accuracy here, right? Because 32 bits, 8-bit, duh. Well, yes and no, right? It depends. And in any case, you can set a target here. You can say, I'm not okay if you lose more than 3% accuracy, okay? You could customize that. And so I'm just loading that config, okay? Actually, I'm loading that config file from the hub. I'm creating a quantization object with the internal neural compressor, and I'm calling fit, okay? And so what happens in the matter of minutes or so, I can see that I started from a model with an accuracy of 42.56%. Okay, it's a very tiny set I'm using here. And after one pass, my accuracy is actually 42.79. So what do you know? This model is actually a little bit more accurate. The quantized model is a little bit more accurate. And it predicts the evaluation set in 12.89 seconds instead of 17.99 seconds. So that's almost I'm going to say 30%. 30% faster, just doing this. And it's a tiny bit more accurate. What's not to love, right? And of course, you can go and look at the models and see that, yes, some of the operators, the linear operators, have been replaced with the dynamic quantized linear operations, which are hardware optimized and just plain faster, okay? Hardware optimization has never been simpler. All right. That's really what I wanted to show you today, that quick tour through the Hugging Face family. It's the whirlwind tour, obviously, but machine learning code, not really. DevOps, not really. Simple code, copy, paste, adapt, experiment, iterate, go super fast. If you want to get started, this is the one slide you want to take a picture of. Of course, you can join Hugging Face. You can learn a whole lot more about machine learning tasks and transformers, and go ask all your questions in the forums. And if your company, if your organization needs help, we're here. We have a support program and engineering support program. And if you'd like to have all those tools on your own infrastructure, because you cannot use public cloud and you got to run on-prem, for example, we can do that too. All right, looks like jet lag didn't kill me. Now I can crumble. Thank you very much. I hope you liked it. Thank you.